Hi everyone, we are here to show you our design for multi-stage air filtration system. Simply put, we built a high-tech breathing system for electronics factories to keep both the machines and the workers safe. So why is this need? Well, SMT factories face three big enemies. First, dust. Even a tiny speck of dust can ruin a circuit board, causing it to fail. Second, fumes. Soaring creates smoke and gas that are bad for people to breathe. 3. The price tag. Most systems today are either way too expensive or they just don't work well enough. We want to find a sweet spot in the middle. So our solution is a three-in-one system. First, we use 4 layers of filters, from basic dust catchers to hospital-grade HEPA filters to make the air crystal clear. Second, we pump air into the positive pressure. This acts like an invisible shield, pushing air out of the door so dust can float inside from the hallway. Finally, we do all of this while keeping the cost low and making it practical choice. This shows the structure of our projects. I'll explain it later. This is our workflow. Break down the intake system. To get the air perfectly clean, we use 4 stages. First, the pre-filter stops big dust. Then, the fine filter catches smaller particles. Next, activate carbon, soak up chemical smells. And finally, the HEPA filter removes 99.9% of the tiniest microscopic germs and dust. This ensures only pure air enters the room. Next is local extraction. This is like a vacuum place, like where the smoke happens, at the soldering machine. It pulls harmful fumes to its own HEPA and carbon filter immediately, so workers never have to breathe in those dangerous air. The last part is the general exhaust. This system pushes all air out of the building. By controlling how much air leaves, we can keep the room at a positive pressure. This means clean air is always pushing out, which stops dirty air from leaking into the door. Here are our main results. First, we reach an airflow of 5,600 cubic meters per hour, which gives the room fresh air in 50 times every hour. Second, we kept the positive pressure between 5 and 15 Pascal to block dust. Finally, we kept the room comfortable at 22 to 25 degrees Celsius. This means better quality of the PCB, a safer room for workers, and lower cost for the factory.